In this next part, we're going to have H1 at 192.168.1.10, that's its IPv4 address, send a packet, an IPv4 packet, to 192.168.2.50, host H3. So H1, the source of the packet, builds the IPv4 packet. The source IPv4 address is its own IPv4 address, 192.168.1.10. The destination IPv4 address is the final destination, that of H3, at 192.168.2.50. Now H1 needs to determine, is the destination IPv4 address, that of H3, on the same network as myself? Now, once again, it knows that its IPv4 address, 192.168.1.10, that it's on the 192.168.1.0 network. It looks at the destination IPv4 address using its own subnet mask. It determines that the destination address is on a different network. It is not on the 192.168.1.0 network. It's on 192.168.2.0 perhaps. All it knows is it's not on my network. So H1 says, okay, I cannot send this packet directly to the device. I need to send it to my default gateway, the router. So H1 knows the IPv4 address of the default gateway of the router. That's part of the configuration information every device must have to reach other networks. So it knows the IPv4 address of the router is 192.168.1.1. What it needs to know is, what is the default gateway? What is this IPv4 address's MAC address? So it checks its ARP cache for that MAC address. We're going to assume that it already has that information in its ARP cache. The Ethernet NIC associated with this interface, with this router's interface, we're going to abbreviate it at 1111. And again, if it didn't know that information, it would send out an ARP request, get an ARP reply from the router. Okay, so now this Ethernet frame gets sent from H1 and is received by the router. The router receives this, says, yes, that's my destination MAC address. This frame is for me. So what it does is it actually removes this Ethernet header information. Now the router is going to do its job at what we call layer 3 forwarding. It's going to do routing. It looks up the destination IPv4 address of the packet. It looks that up in its routing table. It says, okay, this destination IPv4 address, 192.168.2.50, oh, that's a member of the 192.168.2.0 network in my routing table. I can reach that network by sending the packet out fast Ethernet 02. So it wants to send this packet out this interface. So it's going to encapsulate it now in a new Ethernet frame. So the new Ethernet frame will actually have the source MAC address of this router's network interface card. So it's actually going to have the source MAC address of 2222. Remember, Ethernet layer 2 is for network interface card to network interface card communications in the same network. Okay, we're almost there. The next thing it has to do is says, okay, oh, the destination IPv4 address, that's on my network. I, router R1, can reach that device directly. I need to know the MAC address associated with this IPv4 address. So guess what? It actually checks its own ARP cache for that information. And we're going to assume that it has that information, that it knows that 192.168.2.50, this device right here, has the MAC address CCCC. Again, that's abbreviated, but let's go ahead and use that. CCCC. So now it can send this Ethernet frame out the fast Ethernet 02 port. The switch forwards that on to H3. It says, yes, the destination MAC address that is associated with the MAC address of my NIC card. This Ethernet frame is for me. It receives the packet. It says, yes, that IPv4 address is my IPv4 address, receives the packet. And that's how a packet is sent from H1 to H3 across different networks.